So we're here. Oh, I should mention these hacking workshops are coming around every Friday. Feel free to come to these. The next one's at 10 a.m. in this room on Friday, and at 1 p.m. there'll be a lockpicking. And those are both worth extra credit in any of my classes. And so for today, we're down to authentication. So let me bring up the chapter for authentication, which is here. There we go. All right. So, put this, yeah. All right. Good. Do you mean Trump discouraged flu shots? Yes. RFK primarily, but also Trump, yes. A large number of Americans, mostly Republicans, no longer believe in vaccines of any kind at all. So it goes. Anyway, all right, so you have authentication. You have to somehow prove who you are. Identification is claiming to be somebody with a username. Authentication is proving somehow that you are that person, usually with a password. Unfortunately, the password is the cheapest and most common and least secure method of doing it. It would be much better if you had a multi-factor method like a password and a hardware token. You could have SSL certificates, which are what the new pass keys are. They're a cryptographic document that proves that you are the possessor of this file, or smart cards, which are the same thing put on a card like the common access cards used by the military, and so on. There's older Windows integrated services that automatically log in when you're logged into a Windows machine. These never became very popular on the internet, but they're used inside Microsoft networks, especially NTLM. And Kerberos is used in Active Directory. They're all just ways of, so you have these old-fashioned RSA tokens, so the way you did two-factor for a long time. Now most people are doing it with passkeys or apps on their phone. Well, I suppose most people are probably doing it with SMS. And SMS is the weakest and lousiest form of two-factor authentication. It's better than single-factor, but the problem is the phone network is very easily hacked because it uses a very old system called Signaling System 7, and that has been broken for decades and it's too expensive to upgrade. So a lot of people are intercepting SMS messages. So if that's your second factor, a lot of hackers can get it. It'd be a lot better to have an app on your phone, and even better to have a passkey which verifies you biometrically on your phone. But then other alternatives use hardware tokens. Anyway, some second thing that is not your password. Let me say these client-side SSL certificates, and we'll talk about JSON web tokens at the end and SAML, other ways to do it. These are the digest ones I mentioned that have been around for a long time to automatically log in using your Windows login. Now, for a while, there was a big I think it's still true. Third-party authentication providers are a big deal. If you go to any website and almost any mobile app, when you go to log in, they don't really want you to log in with their servers. They want you to use Google or Facebook or something like that. That's better for most people. That way you don't have to handle the password. You don't have to handle password resets and all that jazz. You just let this big company do it. And as long as they're around, as long as all your customers have an account at, say, Facebook, you're okay. And so Microsoft has offered this, and many different companies offer this third-party federated authentication. And Obama wanted to do this. Back in 2011, he wanted the U.S. government to provide the authentication service for everybody because he found out that the average tech worker at that time had to remember like 15 passwords. He said, well, the U.S. government will just handle authentication, and after you log in with the U.S. government server, everybody will just trust that. And this died in death within the week. I mean, because the U.S. government is notoriously insecure, and nobody would trust a bank to be authenticated through there or anything, and there's a lot of other reasons. You also wouldn't want the government controlling all that and being able to turn it off. Well, Obama did a lot of this. He proposed something, and then a couple of days later, he'd pretend he never said it. And it turned out to be a failure. Anyway, so we see all over the place, log in with LinkedIn, log in with Facebook, and so on. All right. And so the way it works, of course, is you send a request, you go to the pop-up box, it goes to Facebook and logs in, and then Facebook sends some of the information about you back to the website. So they don't see your password, but now they know, say, your username and maybe your email address or something, so they can they know that much information about you. All right. So the most common design flaw is that people have bad passwords that can be guessed or that they are in dumps, still set to a default value, that sort of thing. And so if you want to check your password quality, check the rules. If your self-registration is possible, try to create weak passwords. If you control a single account and password change is possible, try to change it to weak values, see what you can get away with. And then there's lots of brute force attacks. The main thing you do is get a list of known passwords, like in the Kali database, they have the RockU list, which was the first really big dump of like 1 billion passwords. And you just try all them. Now, a properly designed website will not let you try more than, say, 10 times in half an hour, and then it'll lock you out for a while, because a real user, if they try 10 times and they can't get in, they should call the help desk or something. They shouldn't keep trying more passwords. The only people that are trying a lot more passwords than that are bad guys, and you should just lock them out. So your password guessing attack, we'll be doing it later. You do it in Burp. Burp has a attack that will just try out a whole list of passwords, and it'll just record the status, the HTTP status of the response and the length of the response. And the point is, you'll probably get a different value for a successful login than an unsuccessful login. So the one that's a different size is probably the one that got it. A pretty simple way to detect it. So you should have some kind of counter, how many times has someone failed to log in, and some kind of lockout when they guess too many times. Sometimes, even after you've been locked out, the page continues to have information, like it might take a different amount of time to process a bad password than a good one, and not show you the answer, but you might be able to measure that time, that sort of thing. You might have verbose failure messages. Here's a common thing you used to see. It would tell you password is incorrect or user is not recognized, and that's very bad, because then I can just guess users until I stop getting this message, and then guess passwords. It lowers the number of guesses by a lot. If I have 100 guesses for username and 100 guesses for password, I would have to do 10,000 guesses to do every combination, but now I only have to do 200. First I do the users alone, then I do the password. So this is not recommended anymore. It should just say your login is rejected, try again, without telling you which part was wrong. All right, and this happened, there are a lot of flaws happened here. This was the AT&T hack. AT&T had a system where you could feed in your IMEI number or some other number from your phone, and it would give you the email address associated with it. And so a hacker just wrote a script that tried them all. And at that time, just knowing that number was enough to authenticate for all the apps on your phone. So you could just log in as somebody's Twitter and everything else and use it. It was, he actually got some prison time for that, I think. This was the script that did it. All right, anyway, there's a script to find phone numbers on the website. Anyway, so username enumeration is some way to find out what usernames are valid, and that is considered a loss of confidential information, not as bad as passwords, but still that we might be able to use to make a more convincing email, more convincing spear phishing email or SMS using the right name for you to help convince you it really is the company asking you to do something. And like I say, here's another common flaw. If you have some subtle difference, like burp comparable, compare two responses. So they're similar, but this word just changed to that word. And so the response when you have a valid username as opposed to an invalid username, even though you can't get in, the response might be different in some way. And if you can find any difference, then you can use it to help enumerate the usernames. So let's try a Kahoot. This is 6A, and I should have them. NTLM is the hashing mechanism used by Microsoft for password storage locally and also sending it over the network. It's based on MD4 because it is so old. It was invented in 1993 before MD5 had even been invented. So it's pretty notoriously weak. It's stronger than the previous one Microsoft used to use, but it's weaker than Linux and Mac by about 1 million. You can guess about 1 million times as many guesses per second against a Microsoft password hash as you can against a Linux or Mac hash. But the earlier one, called LM, was even much weaker. So this is the upgrade that brings it up to 1993 level of security. online and 4 in the room. I imagine there will be more coming. All right. Maybe we got those that are coming. All right. So what's the most common form of authentication? Name and password, and that will probably always be that way. I was arguing with a client just last week telling them they need to go to multi-factor and they're not doing it at all. It costs money. The cheapest and simplest thing is just a password. It will probably be the bottom of the food chain forever. All right, what did Obama propose? Yep, he wanted to make a government authentication service. In fact, the private sector has become the standard. Google, Facebook, and so on. You could argue that instead of trusting those companies, we ought to trust the government. But anyway, that's not what has happened. All right, what defense will lower the risk of a brute force attack? Microsoft Windows has these password complexity rules, which are completely misguided. They just try to make sure you have an uppercase letter, a lowercase letter, and a number and a special character in your password. And that means you're not going to find it in an ordinary English dictionary. But for decades now, there have been dictionaries of stolen passwords that often meet those rules, so this doesn't really help. What helps is a lockout counter. Don't let people try to log in more than a small number of times before you stop letting them try. So you can't try thousands and millions of passwords. All right, what side channel may let you enumerate users even when error pages are identical? Timing is the side channel that even if the page is completely identical, the time it takes to load may be different. And we've done that in projects for SQL injection. All right. Try to find some way to turn off all this stuff or move it to the side that gets big. I never want it. Just like most modern user interface features, all I want to do is figure out how to turn them off. And this could go away too. Anyway. All right, good. I saw a good page on how to take the irritating things out of Windows. That would be great. I would like a similar one to tell me how to turn off the irritating things in Mac OS. All their advanced OS user interface features just get in the way. Anyway. So the credentials might be not protected in transit. People might be on your local network sniffing or in your ISP on the backbone. You know, their traffic does go through many servers between you and the destination, and in principle, there could be eavesdroppers at any of those levels. If you send them unencrypted, then anybody in there can read and modify the data. HTTPS prevents a lot of these. It prevents the people in the middle from being able to read or modify the data. The problem is when it gets to the end, it's decrypted, and then attacks can happen. Things like SQL injection and so on. And once it's at the other end, it may be put in logs and handled insecurely. So, but all HTTPS does is protect it in transit from the source to the destination. All right, so web apps may put credentials in cookies, so even if you can't decrypt a cookie, they can be reused. This used to be quite common, I don't see it so much now, where a login page opens as HTTP and then uses an HTTPS request in the form. This was the standard for banking websites until maybe about 5 years ago. Now everybody's moved to 100% HTTPS as far as I can tell, which is much better. And it's now understood that if you have any non-HTTPS, HTTP-loaded features on a page, that's unsafe because anybody could intercept that portion of it and modify it and add JavaScript to it. So you could have code injected onto your page. That's why your whole page should load over HTTPS. HTTP should really not be used anymore for pretty much any purpose. All right, and the password change functionality, unfortunately, the US government for a long time recommended that everybody change your password every 90 days or 30 days or something, which never made a lick of sense. And about 2 or 3 years ago, they removed that recommendation, saying, we've discovered that this doesn't protect you in any way. All this does is irritate your users, so they typically choose worse passwords and write them down all over the place. But I wonder how they ever thought this was going to help. That the fact that if an attacker steals a password, they're only going to get to use it for 90 days before you change it. That somehow that's making you safer. I don't know what they were ever thinking of. Anyway, what they say now is change your password when you believe it's been compromised, but don't force people to change them on a regular schedule. But everybody I consult for and this college forces you to do it every so long, which has the usual effect that everybody's just constantly irritated by having to change their password. And they usually just go to a simple system of adding another digit to the end or something. Anyway, the password change systems are often vulnerable. Sometimes they'll tell you if the username is valid. Sometimes they'll allow unrestricted guessings of the existing password field because that doesn't count as a login, that sort of thing. Sometimes they validate the existing password field before comparing the other fields, so you can test passwords without making any actual change and without putting anything in the log, because an unsuccessful attempt to change your password probably isn't logged anywhere, but it might reveal whether the old password you fed in was correct. So here's what you ought to be doing. Identify the user, validate the existing password, consider your account lockout features, then compare the new passwords and feedback error conditions to the user. That's a complicated path. It may sound simple, but it's very easy to make mistakes there, and often there are logic flaws in there that either let you trick the system, like there's an app one thing you can do sometimes is you can change the password without really knowing the old password, or you can somehow use it to leak out information. And the forgotten password functionality is typically the weakest link. This is the fundamental problem. If your users have passwords, they're going to keep forgetting and losing their password. And now what do? The most secure thing would be to make them go in person to like a help desk with an ID, but that's really expensive. And if you're an internet service and your users are far away, that's completely impossible. So now you typically have some really weak system, like what's your mother's maiden name or something. That's called identity proofing. And if you have that, that's a backdoor into everybody's accounts. So it's a fundamental problem. Nobody's found a good solution for this. By the way, one thing I audited a few hundred more Android apps in the last week or so, and one thing I found is ones I heard about in Pulse Security Weekly. More systems now don't use passwords at all. All they do, every time you want to log in, they send you an email, and the email has a link or a code. And they just don't bother with the password. They just tie themselves to your email account. We're going to send you a code, put in that code to get in. It's another way to avoid handling passwords, and it really is as secure as anything else. All right, because this is typically what the password reset function is. You put in your email, and it sends you a password reset link to your email, so you might as well, access to the email is taken as proof of who you are by most systems. All right, so if you let them ask questions, you often let them choose their own questions, and they might choose really weak questions like, do I own a boat? There's a yes or no answer. That's a problem. Password hints are often obvious. Even when the questions are chosen from a list, like Windows 11, when you make an account now, will let you choose from a list, but they're pretty simple, like what city did your parents meet in, what college, what's your favorite school or something, and anybody can go online and find your resume and see what schools you went to and have like it must be one of them. So it's the kind of thing. So it's often vulnerable. Some apps disclose the forgotten password to the user. Some let applications immediately in after the challenge. So all you need to do is answer the proofing question and you're in. You know, these things tend to happen. This happened to Sarah Palin. She was doing government business when she was a vice presidential candidate. She was doing government business from a Yahoo account or from her non-government account, and somebody got in her Yahoo account, which she was using, because all they had to do was guess where she met her husband. And it was like at the town her high school was in. So it's a question that was easy to answer by just looking at Facebook and such. Anyway, all right. Sometimes they let you change the email where the password reset link is going to go, so you can just, the hacker can just change it to that. Some apps let you reset the password and don't notify the user with an email. By the way, I got a call today that said Google is changing the phone number tied to your Google account. Press 1 if you don't agree to that. And that sounded bogus to me, and I Googled it. It's a known phishing attack, but that's it. If I had pressed 1, I guess something bad would have happened. But that's the kind of thing. What's that?
Get a new number.
Well, yeah, in fact, what they said was, the bad guy is in fact changing your phone number now, and the one you're pressing is you agreeing to that. That's the trick. That's what I read. What's that? Change the PIN, you say?
No, to swap the SIM, they can. So there's a paid service, like it's very cheap.
The SIM, yeah, SIM swapping. That's true. Well, SIM swapping, they'd be taking over my phone, and I wouldn't know you in the loop. But maybe I'm agreeing to let that happen. That could be, yeah. Anyway, and so of course, Remember Me is a tough one. So you don't want to keep having to log in every time, especially on a mobile device, so it remembers who you are. And the question is, how does it remember you? And one way it can is by storing a copy of your password on the device and sending it up. That's a really bad idea. What it ought to be doing is having a cookie with some kind of session state, but the session state should be a long, unpredictable random number. If it's just a short number like this, then you can just change that number and get in somebody else's account. So anyway, and these things, these authentication cookies are typically valid forever. So once you steal one of them, you can get in people's accounts. All right, and you can steal that if it's not encrypted on the wire. You can steal it by sniffing the network traffic, but now everything is HTTPS, so you steal it with JavaScript by cross-site scripting. All right, so sometimes help desk people can impersonate users. They can log into your account to fix a problem. And so they'll have some function like this, and if you can get access to that function, you can use it to get in people's accounts. And this is something Microsoft did for years. Windows 95 only paid attention to the first 8 characters of your password. You could make it as long as you wanted, but only the first 8 characters mattered. And also Hotmail did that. You have a couple 16 characters. If you're using more than 16, only remember the first 16, and so on. This is senseless, but people do it. And there's also non-unique usernames, which, by the way, I found was true of Phil's Coffee. I sat there. You could make 2 accounts with the same username and different emails, and I wondered if somehow you could cross from one to the other, but there was apparently an invisible identifier, so you couldn't. I tried testing it. But this is, you may be able to make an account with the same username as an existing account, like admin, and then confuse some part of the system to giving you that process. You can have automatically generated usernames that are predictable. Your book tells you to have unpredictable usernames. I don't know anybody that does that. Like, as you know, at this school, it's like the first letter of your first name and your last name, and then like a 2-digit number. It's the same for faculty, so it'd be pretty easy to just take a list of student names and guess their username. As far as I know, that's always like that. I don't think they're doing this anymore. Maybe you people can tell me. For years ago, when this all started, everybody's password was all set to change me, all the same. Then they started making your initial password your birthday. I think they're still doing that, aren't they? All the student accounts start with a password equal to your birthday. That's the way it was for years. That's also a pretty terrible practice, because you could pretty much guess how old somebody is, and you don't have too many guesses to guess the birthday. But anyway, and you can send the password somewhere unsafe, like email or SMS. One thing to know is that if there are default passwords, a large number of your users will never change them, unless you force them to. So then you can just get in anybody's account anytime. And this, of course, led to the huge phone hacking scandal in Britain. It was an open secret that all you had to do to get in anybody's phone message account was to just type in the last 4 digits of their phone number. That was the default, and nobody ever changed it. So for years, the tabloid newspaper was just getting in all the celebrities' phone messages and listening to find out what movies they were on and what scandals they were in and who they were sleeping with and stuff, and publishing all these articles. And it took them years to figure out how they were doing it. But everybody's voicemail was essentially public for years. So the kind of thing tends to happen. And that's why we all need to move to two-factor, because those things are so many flaws in these single-factor authentication methods. Anyway, let's try another Kahoot. The voicemail had a 4-digit PIN to get in, and by default, it was just the last 4 digits of your phone number. So if you knew somebody's phone number, you could get in their voicemail. And that worked for almost everybody. It was that way for like a decade. Might still be that way, actually. I haven't tried accessing my City College voicemail in a while. All right, so what does HTTPS prevent? Prevents eavesdropping. People cannot take your network transmissions and figure out what your password is in there. All these other attacks still work. This is cross-site request forgery, where you send a request which is run on the wrong server. Trick a different server into running a request than the one it should be running on. And all those work because those rely upon the message being misunderstood once it reaches the destination. But eavesdropping is intercepting it in transit, and that's what HTTPS prevents. All right, what functionality is often a simple persistent cookie? Remember me, and I see Joe's point. Yeah, of course, in the early days you'd hack phones with the blue boxes and such by just putting tones. Yeah, I never did that. I wasn't in the game then, but I heard about it. Yeah, that's what Steve Jobs and Bill Gates started with those things long ago. All right, which one is insecure because it doesn't validate all the fields in the correct order? Password change is a complicated process with many fields that have to be validated, and it's easy to make a mistake. All right, which one might use a backdoor password that works for all accounts? Yep, that's user impersonation, some way to get into another account. It used to be very common that every product was shipped with a permanent backdoor that the manufacturer knew so they could get in to perform maintenance. That has not been considered an acceptable practice for decades, although it keeps happening. And there are persistent rumors that Windows has a secret backdoor account. I think that's false, but how would you ever be sure? Anyway. All right. G will have to tell me who they are if they want their points. So, keep going, I see. All right, so then there's flaws in implementation. It may happen that you can get in by putting in a special password or a username that's misunderstood. Some of my automated scoring system questions in early version, students found out that if you just left the answer blank, it would treat that as true. And it's easier to make that mistake than you might think. Anyway, that's the sort of thing, putting in letters where numbers are expected or long or short values can often cause an exception, and sometimes the result is to let you in instead of to eject you. Multi-stage login is where you have a username and password, then you have like a CAPTCHA for a PIN and the value displayed on a token. That's one way you might do it. And the problem is you might be able to skip steps. You might be able to put data for step 1, but somehow when you get to step 2, the user changes it. So what you have to do, if you have any kind of multi-stage process like this, you have to put in a token, a random changing hidden field value in each page. So when you go to the next page, it can verify that you did come from the previous page and you didn't just jump the line. They talk about this a lot in your book. All right, so multi-stage login, it might use a randomly chosen question to verify the user, but maybe I can alter the question. Or maybe it'll allow me many requests so I can just keep trying it until I get an easy question, that sort of thing. And the credentials have to be stored somewhere. In the very early days, like the 1990s, they were just stored in a plain text file, but people figured out that was no good. Instead, they run them through a hash function. But the problem is Microsoft hash functions are pathetic. It's 1 round of MD4. Linux is 5,000 rounds of SHA-512 with assault, which is a lot better. But still, if you get a copy of the hashed passwords, you can then try millions of passwords offline on a fast system to crack in. Somebody told me who they are. Good. I see your name there, G. I'll put it here. Good. Good. All right. Anyway, so when you're making your authentication system, like all security decisions, it's always a balancing act. There's no perfect security, and at some level, your security measures are so strict that they irritate your real users and inhibit work. So you have to make a reasonable judgment. How inconvenient can you be? How important is security? How much is it going to cost? If you make it too hard, you're going to have to spend a lot more time on help desk and recovery methods and so on. So you have to make a calculated decision, what level of security is appropriate. So with strong credentials, you have a minimum password length requiring a mix of characters, no dictionary words. Username should be unique, automatically generated usernames or passwords, and so on. Allow users to set strong passwords. These are ways to be better. Protect your passwords when created, stored, and transmitted using normal cryptography. You don't invent your own cryptography. That is always a mistake. The smartest mathematicians in the world have worked very hard to make the standard methods as good as they can be. Just use them. And of course, the whole page should be HTTPS, not just the login button. And your stuff should be sent with post rather than get, so it doesn't end up in logs. Don't put anything sensitive in URL parameters or cookies. Don't transmit credentials back to the client. And hash credentials on the server. That gives you some time to respond to a breach, as it'll take the attacker some time to crack those hashes. So hashes are, you just run a password through a hash function like MD5 or SHA-1, and that's the hashing. Salting is a good idea, where you add some random characters to the password before hashing it. That way, if two users choose the same password, they don't have the same hash. And then you have to store the salt along with the hash. So the algorithms take your password, add these 8 digits to it, and then hash it with 5,000 rounds of SHA-512, that sort of thing. So this is the login.defs file in a Linux distribution. This is Kali, and it shows you how it works here. We're using SHA-512, 5,000 rounds. All right, so your client-side Remember Me functionality should only have non-secret items. If you allow users to store passwords locally, then they should be encrypted in a key known only on the server. This is the mistake almost every Android app makes. All right. They store the password somehow locally, and they also store the key locally, so all you have to do is read the source code and find it, and you can get in. Like I say, this was something everyone's believed forever, is you make your users change password periodically. This is no longer recommended, but almost nobody's gotten the message. Everybody is doing this, even though it's stupid and counterproductive. Consider what you're going to do with new users. That's a problem, like I say. A lot of people give all new users the same default password, and then a bunch of them never change it. All right. Another thing you can try, by the way, is use drop-down lists instead of text fields to defeat keyloggers. That's one, then you're actually not typing the password. I've heard of that. I've never actually done that. Some people use the on-screen keyboard trying to avoid keyloggers and such. So validate the entire credential, terminate the session on any exception, look at your logic and code, consider how your help desk is getting in accounts, maybe the weak spot. And if you have a multi-stage login, then all the data should be held on the server. You should never trust anything coming from the client. You shouldn't let the client tell you, I already did step 2, here's step 3. Your server should know whether they already did step 2 and not believe the client claiming that. All right. And so the first task could be to make sure that all prior stages have been correctly completed, so they can't jump to step 3 and brute force that one piece without doing the pieces before it. And even if they fail on step 3 out of 5, you go through all the steps and then tell them they failed. Otherwise, you create a shortcut for them to enumerate the username or the password. All right. So all authentication failures should use the same code to produce the same error message, so it's exactly the same and it takes the same amount of time. Otherwise, if you have a copy of the code that's a little bit different, then you're likely to leak information. And you should be using account lockout. Login attempts with invalid usernames should lead to the same error message as valid ones, and too many login attempts should get locked out. If you allow users to choose usernames, then they're likely to choose easy ones. What's better is most people use your email address as username, or they generate unique. Nobody does this, unique unpredictable usernames, but they often use your email address. Anyway, to prevent brute force attacks, at all these places where passwords are handled, you usually disable an account after several failed logins. For a lower security case like a company, it might be enough to just freeze it for half an hour after 5 failed logins. Then then your normal users have half an hour to hunt and find their password, and it's still enough of a lockout to slow down people that are brute forcing their way in. And CAPTCHAs are very popular these days because, of course, so many people are using programs. A CAPTCHA is intended to make it so you know there's a human logging in. I must say, this is pretty much a failure. I find the CAPTCHAs very hard to solve myself. I have quite a few students who are constantly confronted with those 3x3 pictures, and they have to go through like 6 or 7 of those before they can get it right. And now the AIs are getting very good at doing it. In fact, AIs are actually better at solving these CAPTCHAs than humans now, I think, which kind of defeats the entire point. And even before that, the attackers would write systems that could break through them. These things are of dubious value, but if you don't even put that there, then people can just run thousands of guesses per second. So anyway, all right, there should be no way to change the username. You should have to put in the old password to get in the new password, and be sure that you notify the user that the password has been changed, so if somebody else does succeed in changing it, they will at least have some chance to detect it. And have some way to recover your account if you fail with your password, and consider how weak this is. It's usually very weak, and therefore almost every company is much less secure than they think they are. Challenge questions are considered terrible and not approved by any federal compliance standards, but a lot of people use them. And so you should log authentication of the related events and use them to identify suspicious activities and lock them out. Anyway, let's try another Kahoot. All right. All right, so which system might let you in with an invalid or blank username? Yeah, that's fail open, where an error condition leads to success. How should you store your credentials? Yep, salted and stretched and hashed. All right. And what happens if you fail at the first stage in a multi-stage login process? Complete the process, then show an error. If you do any of these things that cut it short, then they can use the incomplete process to brute force information. All right, what functions should use auto-generated usernames to prevent enumeration? Yeah, they recommend it for self-registration. I've never seen anybody do this. This is considered so annoying that nobody does it. I do remember CompuServe did this in like 1991. Your username was like a 10-digit number, and you couldn't change it. But I think I've never heard of anybody using that system again. It would be cryptographically more secure, but it's so irritating for the users that nobody I know does it. Anyway. Okay. All right, and I think I got just a few more things to mention here. Yeah, this one here, I don't recommend this challenge anymore. I'm not sure it works, but it is interesting. This is what Canvas uses, is Security Association markup language. And what happens is when you send your password in to the identity provider, then they will reply with a cookie that comes back. And the cookie is, this is a SAML response, is a big blob of data, and that is like an ID card. And that includes assertions that you are this person and whether you're the administrator and other things, and then a cryptographic signature to verify it. And in early days, maybe 8 years ago, a bunch of servers had a flaw that they didn't actually properly authenticate the signature. So you could modify that response and claim to be the administrator, and it would fall for that under certain conditions. So there was I made a challenge here where you get in by successfully impersonating someone. And as I say, I wouldn't bother with that project anymore because I think they've updated all those SAML processes, and this is no longer a common attack. But you can do the same thing with JSON web tokens, which are very common and used all over the place. And so JWT tokens consist of 3 base64 encoded sections, a header, which tells you the algorithm and type, then the payload, which is data showing like your username and whether you're the administrator, and then a signature, which cryptographically signs it. And the signature includes a secret. And so the attacks are, sometimes it fails to verify the signature, so you can just modify the payload and get away with it. There is an algorithm called none, where there is no signature required. Sometimes you can change it to the none algorithm, and the server will accept that. There's a secret called the HMAC key, and sometimes that's a short thing like a password, and you can guess it. And there are other things that can happen, and we'll do some projects on these in the Web Security Academy. Anyway, that's it for the lecture. Let's take a 10-minute break and pick up at 7:10. Stop this.